Welcome to Lecture Online, and now we're going to do an example where we find the area between those two curves right there. Notice they're both quadratic equations, they both look like parabolas. Looks like this is a parabola that opens upward, this is a parabola that opens downward, so they probably will enclose some sort of area we're trying to find at. Before we can really figure out what to do, we should graph those two equations to give us a better idea what it looks like. It's always a good idea to graph it. So here's our xy axis. And so this is a parabola opening upwards. The best way to figure out what that looks like is to quickly factor this and set it equal to 0, because that's where we cross the x-axis. So if we take this equation and we write it as 0 is equal to x squared minus 2x, and then we factor in x, so we have 0 is equal to x times x minus 2, you can see that it crosses the origin at x equals 0, and it crosses the x-axis at x equals 2. So there's a point where it crosses. There's a point where it crosses. This is 1 and this is 2. And so since it's a parabola that opens upward because the x squared term is positive, then the parabola will look something like this. Again, it doesn't have to be exact. It just has to be a sketch so you can figure out what you want to do with this problem. All right, doing the same with that one. Notice that this one will open downward because the x squared term is negative, and if we then set that equal to 0, 0 equals minus 2x squared plus 7x, we do that to find the roots. We now factor out an x, so we get 0 is equal to x times minus 2x plus 7, which means that x equals 0, or x equals, it looks like 3.5. All right, so that means that it will cross the x-axis at the origin, and again at x equals 3.5, so let me make that a little bit bigger. So this is 3.5. There's my x-axis. It's a little confusing here. There we go. So my parabola looks something like this. And it goes to the point right there. And notice that there'll be an intersection between the two graphs over there, and there'll be an intersection between the two graphs over there, which means when we try to find the area, it's going to be this area right here that we're interested in. All right? In order to figure out what the limits of integration are going to be, we need to know the points where they cross. So here we have the intersection 0, 0, and now we need to find the intersection where they cross over there. To do that, we need to solve the two equations simultaneously to figure out what this spot is right there. All right, let's do that. So we have x squared minus 2x is equal to minus 2x squared plus 7. Moving everything over to one side, let's move the right side to the left side. So we have x squared plus 2x squared, because when we move across the equal sign, that becomes positive. So we get 3x squared and minus 2x. Oh, did I forget an x? I certainly did. It should be 7x. So when I bring the 7x across the other side, that becomes a minus 7x. So for a total of minus 9x equals 0. So to solve that for x, I can factor out an x, and I can divide both sides by 3. So this gives me x squared minus 3x equals 0, or x times x minus 3 equals 0, which means that the two functions cross at x equals 0 and at x equals 3, which means that right here, this is the point 3, and of course my y value, all I have to do to find my y value is plug 3 in any one of the two equations. So this would do 9 minus 6, because 2 times 3 is 6, so that would be 3, 3. That would be the point at which the two functions intersect. All right, now I have my limits of my integral. Now I can go ahead and set up a small little area element. So I'm going to draw an area element vertically. The reason why I draw it vertically is that I do it horizontally. Notice that, I guess, it may not work. It works pretty well everywhere, except here we would go from this line to that line, which is the same function. Here we go from this line to that line, which would be two different functions. So we have to integrate it over too many different ways. And so it's better to have your area element vertically. In that case, the top and the bottom of the little rectangle that you draw always have the same curves as a limit. At the top, it's always going to be this function. At the bottom, it's always going to be this function. So it's better to draw your area element vertically. So this is going to be your little dA, which is equal to the height of that rectangle, which would be the upper limit minus the lower, or the upper curve minus the lower curve. So the upper curve is my upside down parabola, which is this function right here. So let's call that y1. And the bottom curve is my right side up parabola, which is this function right there. And let's call that y2. If I do it that way, I can write my dA as equal to the height, which would be y1 minus y2 times the width of this rectangle, which is going to be a small little dx. So the width is going to be a small infinitesimal dx. So I'll write this as a dx. So now I have defined my little dA, my little area element. Now to find the total area, I'm going to sum up all the little area elements, which is equal to the integral of all the little dA's. And I'm going to integrate from x equals 0, which is the left limit of that area, to x equals 3, which is the right limit. So from x equals 0 to x equals 3, which is equal to the integral from 0 to 3 of my dA, which is y1 minus y2 times dx. And finally, since I cannot integrate y's and x's in the same integral, I have to express my y functions in terms of what they are equal into x in x variables. So this would be equal to the integral from 0 to 3 of y1 is minus 2x squared plus 7x minus y2, which is x squared minus 2x. And the whole thing is going to be multiplied by the dx. Notice how putting these subscript there makes it easier to not make a mistake, right? So y1, you look up here, that's equal to this. So plug that down. y2 is equal to, from up here, equal to that. So you don't make a mistake, sometimes rearranging them incorrectly. Now we just have to combine like terms underneath that integral. So let's do that. So the area is equal to the integral from x equals 0 to x equals 3 of, we have a minus 2x squared minus x squared, that's a minus 3x squared. We have a 7x minus a minus 2x, that would be plus 2x or plus 9x. And the whole thing is integrated over the dx from 0 to 3. Now we're ready to evaluate that integral. That integral will give us the area bounded by these two curves. So this is equal to, when we integrate this, we get 3x, add 1 to the exponent, cubed, divided by the new exponent. We can't forget the negative, that's already there. And of course, these 3's will cancel each other out. And then the second, we get 9x, that becomes plus 9x squared, divided by the new limit, the new exponent, which is 2. And the whole thing evaluated from 0 to 3. So now we go ahead and evaluate that integral by plugging the upper limit, and then subtracting from that when we plug in the lower limit. So this will be equal to, plug in the upper limit, we get 3 cubed. And of course, don't forget the minus sign right there. And then we get plus 9 over 2 times 3 squared. So that would be 3 squared. And then we subtract from that when we plug in the lower limit. But notice when we plug in 0, we get 0 and 0. So that would be minus 0. That would be minus 0, minus 0, like that. That makes it easier. Okay, so now we just have to evaluate that. So this becomes minus 27. And this is 9 times 9, which is 81, divided by 2, which is minus 40. That's plus 40.5. Let me check that real quick. 9 times 9 is 81, divided by 2, 40.5. And so the difference between those two, that gives me 13.5. And that would be the area between those two curves. Okay, quick review. You get two curves, you first want to graph them. So you have your parabola that opens upward, parabola that opens downward. You can see that they cross at two places. You want to solve those two equations simultaneously to find the places where they cross. We did that right here. So we realized that x equals 0 and x equals 3 is where the two parabolas cross. Then you want to find a small little area element. You call that height times width. The height would be the difference between this function minus this function. So it would be y1 minus y2. We defined y1 as this function, y2 is the bottom function. Okay, the x is the width of the area element. Then when we want the total area, we're going to add them all up, which is the same as integrating. The limits are from 0 to 3. And then we replace the y1 and y2, but what those functions are equal to in terms of x. Simplify, integrate, and plug in the limits. And that's how you find the area between those two functions.